All right, so let's go through an elevation and depression question. Let's maybe do question 9. Let's go through question 9. The angle of elevation from D to B, is 30 degrees. That means it starts here and it elevates up as 30 degrees, right? We're elevating up. The angle of elevation from D to C, so all the way from here to here, is 45 degrees. So this whole thing is 45 degrees, whereas this bit here is 30 degrees. AD is 20 meters. Find the distance between B to C. Sorry, B to C, right here. So we want to find that distance. Does anybody have any clue of how I'm going to be able to find that distance there? Or what the logic would be to finding that distance there?
130 minus 45.
Not yet. Not yet. What would be the logic to find this side here?
Would you have to find length dB?
dB. All right, so if I did find length dB and you did use what Larson was saying with 15 degrees, you technically can go and find this x, but then you have to use non-right angle trig because it would be a non-right angled triangle, this one here. But imagine you had to use your right angles. So imagine you had to actually use the big triangle and the small triangle here.
Would you find B and A?
You would find B and A, sure, and then what are you going to do? You also need to find what? So you have B and A, let's just say you found that.
You need to find
what else
B and
do you
C.
need? Not B and C, because B and C is what we... Sorry? A.
D.
No, not D and C.
No.
A and C. If you find A and C, and you find A and B, look how easy it is to find B and C. You're just going to subtract them. Can we see that now? So you'll find AC minus AB, you'll be left with BC. Everything else you guys are saying, like find BD, CD, absolutely will work, but you're going to multiply the difficulty by at least 3. So something that might take you, let's say 3 lines, is going to take you now 9 lines. So it's not required to go and do that. Try to really see these subtraction of sides. It's a lot easier. Okay, just since we're on this point, how are you going to find D? Well, you'll find D, let's label this as X. How are you going to find this whole value of D? Can someone tell me?
AX plus BX.
Yeah, and that's going to be the logic. How are you going to find H? Again, this length plus this to this length plus this length to this length. You'll find the whole H. That's usually going to be the idea. Try to see it that way. It'll just make your life a little bit easier. All right, back to this question. So imagine I wanted to find AB. I'll zoom it in so we can only focus on the one bit. There it is. That's 30 degrees. That's 20, and that's AB. So obviously you're going to use opposite over adjacent, which is tan, equals opposite over adjacent, and then of course AB is 20, 10, 30. You plug that into your calculator. It doesn't say exact, so you can just plug it all into your calculator, and it says 11.54 or 11.55. I'll do the same thing for the bigger triangle. What's the angle that I'm going to have here? You're obviously going to have 45, yep. And then this is 20 still, and then you're going to do the exact same thing, right? Let's just say this was AC. Opposite over adjacent, still tan. Tan 45 equals opposite over adjacent. AC becomes 20 times tan 45, which is 20. Therefore, BC is 20 minus 11.55. Okay. Any problems with that question? You guys, 8.45. No, we're pretty comfortable with that. That all makes sense. Question 10, I'm not going to do, I'm just going to show you what I can see, and I think if you guys had no problems with that one, then you probably won't have any problems with this question. This is 50 degrees. Remember, depression and elevation are the same, so that's 50 degrees as well. Alternate angles. If that's 65, this guy's 65, and then I think you guys can tell that's going to become one triangle with your 20, and then so you're going to opposite over adjacent, you'll find this side, and then you'll do the same thing with this triangle, opposite over adjacent, you'll find this length, and then you'll just add them up to get the whole distance D. All right. I think I wrote 45 meters here. It's meant to be 20 meters, obviously. Okay. All right, I'll leave that with you guys to do your own time. If we get time, we'll come and do more and more of them. All right. We should have only done question 1. Let's just recap. Let's make sure we do remember how to do this. So I'll pick a number. Let's do 3, 5. Yep, we're going to do 315 degrees. So we're going to try to do sine 315, cos 315, and tan 315. Can we please try to put these in our exact trig ratios? So use your calculator, see if you can get it out. I'll give you the clue here. It was square it and then mentally square root it. I'll give you a few seconds, plug that into your calculator, write answers down. Okay, sine 315, I can see it says negative 0.707, so I squared it. If I square it, I see it as a half, which means my answer should be at least 1 on root 2. Don't forget, it was a negative, so it's negative 1 on root 2. My next answer, I know is going to be 1 on root 2, and then tan should become negative 1. Does anyone want me to go through this again before we move on? All good? Seriously, did everybody actually get all this right?
Sometimes you do just 1 over 2 without the root. Why?
Yes. Yeah, so that's already exact. So if you try sine 30, it actually just gives you 0.5, which is a half. That's already exact. You don't square root it. So okay. The ones that you are trying to do the square root is like cos 30. If you plug that into your calculator, it says 0.866, blah, 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 blah. It goes on forever and ever. That's not exact. Even if you write 0.86, that's wrong. That's not exact.
Yeah.
So what we want to do is use this trick to actually convert 0.866 and eventually write it as root 3 over 2. But if I got an answer of like 0.5, or in this case, I got an answer of negative 1, that's perfect. That's already exact. I don't need to do anything to it.
Yeah.
Good. Anybody else? Seriously, if you guys can do this now using my method, wow, we just killed it. That's amazing. I hope you can remember that for a very long time. All right. Let's do question 2. I know we didn't do that last week. It says, find the exact value of sine theta and cos theta, given that cos theta is negative 3 over 7, and that theta is between 180 to 360 degrees. All right. So the first thing you got to think about is, sorry, not sine theta and cos theta. Cos theta is already given. Sine theta and tan theta. The first thing you got to think about is how am I going to actually find sine and tan if I've only been given cos theta? Anybody have any ideas of what you're allowed to draw or what you're meant to find sine and tan if you've only been given cos?
Do you draw all stations to central?
You will need to do that eventually for this and the fact that its cos is negative and whatever. So yes, I like that. But how are you going to find sine theta? Like Chan, that was you, right?
Yeah.
Yeah. So if you're given cos theta is 3/7, so ignore the negative for a second, right? Cos theta is 3/7. How are you going to say what sine theta is? Actual sine theta, like that's just confusing, right?
You do sine minus 1.
No, that's squared. Don't mix them up. Cos squared is 1 minus sine squared, or sine
no.
squared. What do you mean?
Like how this the power of minus 1.
Oh, right. No. So cos theta 3/7. Cos theta. What do you know? You know. Okay. What formula do you know for cos theta then, Chan?
Like as in those.
What?
Just the most basic one. Yeah. Cos theta equals.
Cos theta equals SOHCA TOAS, SOHCA adjacent over hypotenuse. SOHCA, yeah.
Right. Yeah, and don't you see that if this just came from a triangle,
Would you draw the triangle?
right? And then you can say there's theta, there's your adjacent, which is 3, there's your hypotenuse, which is 7. Aren't you able to work out this side here?
Yeah.
And then once you work out this side, which is 7 squared, take away 3 squared, and then square root it, which is root 40, are you able to now say what sine theta is?
Yes.
Yeah. So I guess the trick you want to learn from this is if you ever have cos theta, you need to go find in sine and tan. The only way you can do that is by drawing your triangle for your initial case and then working out the third side, and then from there you can work out what sine theta is, you can work out what tan theta is, you can work out anything else. So same thing with this one. It says find cos if sine is this. Well, if sine theta is this, you've got to draw a triangle with that. Then you'll work out your third side, which would be the adjacent, and eventually we can get cos theta. Okay, I'll stop there for a second. I'll let you guys absorb that. Tell me if you've got any questions. All right. Can anyone tell me why I ignored the negative and I didn't put a negative in this triangle?
You can't have negative distance.
Okay. As simple as that. You can't put the negative in because you can't have negative distance for your triangles. So that should solve that problem. The only reason why it's a negative is because it's trying to tell you that cos is negative here. If cos is negative, that means it's probably going to be, if cos is negative, that means it could be in here or in here. But it's telling you the angle is specifically between 180 to 360. That means it's in which quadrant? A, S, T, or C now? If theta is between 180 and 360. It would be right there. Because that would be 0 to 90 degrees. This is 90 to 180. This is 180 to 270, 270 to 360. So it's somewhere in this region, and it's got to be, cos got to be negative. So the only solution is tan is positive, which means this guy and this guy is positive. So sine and cos are both going to be negative. Did that make sense to everybody?
I haven't seen the SATC thing before.
Wait, didn't we do that last week? Did we get time to do this last week?
No.
Oh, no, we didn't.
Oh, we didn't do all stations to central. Oh, all right. We have to come back to this question. That is super important. Wait, so we would have done these. We would have done all the simplifying questions, right?
Yep.
And prove. Okay. Fair enough. Solving. Oh, super important. All right, let's do it. We're going to do all of these anyways. So, oops. Okay. We've got to learn to solve. You're solving for all the angles between 0 to 360 degrees. Now, before we can learn to solve these x's, we got to learn all stations to central. This says that all of my trig identities are positive here. This says only sine is positive here, tan is positive here, and cos is only positive here. So if I came up to you and I said, hey, this, like in this question here, it's saying cos is negative. If cos is negative, that means all of them are positive here, and cos is also positive here. So that means cos would be negative here and here. All right, let's try that again. If I said sine is positive, well, sine is positive here and here, which means sine is negative here and here. But again, where is tan positive? Tan is positive here and here, which means it must be negative here and here. Any questions, Giovanni, for example, at this stage?
What does that do? Like, what does that show us?
Well, we'll get to that soon, but I'm saying, does that all, so if I ask you where is like sine negative, where is sine going to be negative? What are you going to say?
T and C.
T and C, good. All right, at least you get that. That's it. That's perfect. We'll need that soon. Then we'll need our angles. So if your angle falls in here, it's going to be theta. If your angle falls in here, then it's going to be 180 degrees minus theta. If your angle falls in here, it's 180 plus theta. If your angle falls in here, it's 360 minus theta. So if it's here, it's theta. If it's in the sine region, it's 180 minus that angle. If it's in the tan region, 180 plus. And then if it's in the cos region, 360 minus. All right, let's see how this actually works now. We got a question. Question says, solve sine x equals root 3 on 2. We first can tell that sine is positive because it's just root 3 on 2. So if sine is positive, we now know it's going to be in, you know, this region and this region, but I'll do that as we work through this. We're trying to solve. To solve for sine x, I got to get rid of the sine, which means to get rid of the sine, the opposite of sine is to inverse sine or shift sine, and then root 3 on 2. Does that make sense? Then we plug this into our calculator. So inverse sine of root 3 on 2, just plug it into your calculator, shift sine, root 3 on 2, 60 degrees. Then what we ask ourselves is, all stations to central, where is sine positive? Well, sine is positive here and here. So the answer you should get is the first theta, or the first x value, whatever, there it is. The other answer must be 180 minus theta. So 180 minus 60 is 120 degrees. Now I'll stop there because we just solved it. We're done. Does anybody have any questions at this stage? Giovanni, can you see how it was used now?
Yeah, it makes more sense.
Yep. So sine is positive in this region and this region, so therefore your first answer is 60, your other one is 180 minus your theta or your x, 180 minus, which is 120 degrees. And then here, to get rid of the sine, you have to shift sine, root 3 onto. You guys are probably used to that from, you know, last year you were doing angles, shift sine, shift cos, shift tan. A good point to make, so it does say solve it for all the numbers from 0 to 360. This is all the numbers from 0 to 360, that's what this does. But just, I mean, it's a good point to make. Let's just say 60 degrees. Let's just say 60 degrees is right there. If I add 360 degrees or subtract 360 degrees to 60, where will I come back to? Exact same spot, right? No matter what I add or subtract, I'm always back at the same spot. So if you want to try something out, check this out. Put sine 60 in your calculator. And you should say 0.866, which we know now is root 3 onto 2. Then add 360 to this answer. So try sine 420, try sine 780, try sine 1140. Did I add that right? 780 plus 360. Yep. What do they all give you?
It gives you the same answer as sine 60.
Every time, right? And the reason why it does that, Nikki, is because all you're doing, you're getting an angle, you're not changing its position, you're just adding 360 degrees to it. So all of these angles are technically correct. In fact, trig, they go on forever. So they go on forever. For those who maybe have done physics and stuff, you've looked at the curves. The curves go on forever this way, and the curves go on forever this way. So forever. And if they go on forever, this way and this way, we have to give you a domain. And the domain they're going to give you is usually from 0 to 360. So just start at 0, stop it at 360 degrees. So if you've got extra values, like if you wanted to write 420 for any reason, you can. It's not wrong. It's just wrong because the domain stops at 360. So that's gone outside of our domain. But it's a good skill to know that you are allowed to add 360s and subtract 360s as you like, because you're not changing the answer. All the answers are always going to be the same. All right, beautiful. So 4 marks for that. Let's do B. B, tan x equals 1 on root 3. I guess we should do it one by one. So let me pick. Let's start with Aiden. Aiden, let's start with the first one. Tan x equals 1 on root 3.
Yeah.
All right, here we go. First line, what are you going to do?
X equals inverse tan 1 over root 3.
Correct. Then
Which
plug it into your calculator. Give me your answer.
I got 1 second.
Yep.
30 degrees.
Correct. And then stop. What do we draw?
All stations to the center.
There we go. ASTC. And then you're going to ask yourself, where is tan
Positive,
positive?
which is A and T.
And then your first answer is theta, which is, there it is. Your next answer must be 180 plus. So what's your next answer?
210 degrees.
Thank you very much. See, any questions from anybody there?
Why was it A and T?
Why was it A and T?
Yeah.
Tan. Where is tan positive? Do you remember where tan is positive?
No.
No. So let's go up. Have a look again. So all of them are positive here. Sine is positive here. Tan is positive here, and cos is positive here. So if you had to say where is sine positive, you would have said where? S and
Yes.
A. And A. Because all of them are positive here.
What does A stand for?
All
Oh,
of them are positive. And then if I said cos is positive, where would it be?
A and C.
A and C. Where is cos negative? The other
T
two.
and C.
T and S. If cos is going to be negative, it's going to be in T and S.
Yeah.
Do you actually get that? So again, look, sine is positive here and here, right?
Okay.
Positive, positive. But where would sine be negative then? If it's positive up here, where will it be negative?
Down.
It'll be negative down here. T and
C.
C. Yeah.
Yeah.
All right. Let's do the next one. I think it's Chan. Yeah. C. Cos x equals negative.
So do
Wait.
cos.
Wait. So, your teachers, this is again where a section where I don't like to, I guess, change my methods, but your teachers will tell you that for negatives, these regions will change. So these thetas and stuff will change, and they just make it a big mess, right? I don't like to do that. I like to keep everything uniform. It just makes life a bit easier. So our working out is going to be a little bit different to what your teachers will be doing. So be careful. This would be a section that you would want to come back and review, especially once you have once you've started this topic at school. You don't inverse.
Negative.
You'll never see me do it. A negative. Okay, so don't inverse a negative. So you're not going to go shift cos negative root 3 on 2 and get an answer. So what we draw when we're doing negative cases, I like to draw these little hats. So like to say, oh yeah, this is x, but it's not. So x becomes inverse cos of root 3 on 2. Just the positive case. You don't do the negative case. Okay? Chan, makes sense so far?
Yeah.
So don't do it, but you put this because this isn't the answer. It's just an angle we need to actually continue. What is now inverse cos of root 3 on 2?
30.
Okay, once you've worked that out, I'm just double checking if it is 30. Yep. So once you've worked that out, then what do we draw usually?
The all stations are central.
Good. And then what are you going to ask yourself this time?
Where cos is negative.
That's how we're doing it. So my technique, my method, that's the way we're trying to attempt them. Very, very uniform, very similar each time. Where is cos negative this time? Cos
Sine
is
and tan.
negative here and here, and therefore your answers are actually what? So x is actually equal to
31 is 150 and 180 plus 210.
So this isn't your answer. 30 degrees is just there, so when you're doing 180 minus theta, you actually have theta. Or when you're doing 180 plus theta, you actually know what theta is. Don't inverse a negative, and I think that looks pretty good. We might do a few more of those. Good job.
Use.
Giovanni, let's go with, we'll do A and B with negatives. So A has a negative. What was A again? Sine x equals negative root 3 over 2. Okay. All right, Giovanni, you ready?
Yeah.
Let's go. So x with a hat equals inverse sine of,
Root negative root 3 on 2.
no,
Oh, we don't put negative.
don't inverse a negative.
Yeah.
Okay, root 3 on 2. Yeah. Plug it into your calculator.
One sec.
All good.
Um, 60.
60. Now that's not your answer. That's why we've got these little hats, yeah?
Yeah.
So that's there just to say, like, this is kind of what we need, but this is not our x. Then what do we draw?
The all stations to central.
Beautiful. And then you're going to ask yourself, where is
Negative.
sine negative? Yeah. Which is
T and C.
sine negative in T and in C. Do you want to tell me what my answer is now for x?
180 plus 60.
180 plus, so 240.
240, yeah. And then 360 plus 60.
Minus. 360
Oh,
minus.
minus. Yeah. So 300.
That's okay. 300. Done. And then if you want to check it out, Giovanni, look, just put sine 240 in your calculator. You'll get negative 0.866. Put sine 300 in your calculator. You'll get negative 0.866. And you can double check that, and I promise you that'll be right.
Yeah, it is.
Good job. P as a negative. Let's do that one as a negative. I think it was 10x equals negative 1 on root 3. Who's next? Next, Hetvi, you ready?
Yeah.
All right, tell me. I'm not going to talk much. You're just going to say what you think.
Okay, so we do like X with yeah.
Hats?
Yeah,
I
with
say
hat.
hats.
Okay.
Yep.
And then inverse tan, 1, oh wait, yeah. Inverse tan 1 on root 3.
Mm-hmm.
And that is 30.
Mm-hmm.
And then we check like where 10 is negative,
Too
which
good.
essence, which is sine and cos, so like 180 minus 30, which is 150, and 360 minus 30, which is 330.
Now, you just got yourself 3 marks in your exam, you know that? That's amazing. Good job. Simple, please don't let your teachers confuse you when they're going to start teaching you negatives. Like I said, they'll change their domain and they'll change this. All station central, I don't do that. All you got to remember from my end is we don't ever inverse a negative. Your teachers will inverse a negative and that will confuse you, so don't inverse negatives. Okay, we're looking good. I'm going to keep going to some of the harder ones now. We just did those, so let's try these. Who's next? Okay. Larson, you ready?
Yeah.
All right. We're going to do D. D says 2 sine x plus 1 equals 0. Now, you know, whenever you're trying to solve for your letters, your numbers have to be on the other side, right? So you can't have it written like this. So what's the first step you're going to do? Just simple solving. Forget trig. Just imagine you were solving for x. What must you get rid of first?
The 1
Correct. So you're going to have 2 sine x equals,
minus 1.
and then what are you going to do with the 2?
Divide it.
And that looks a bit more like what we've been doing. Can you see that now?
Yeah.
So you got to remember your basic equation skills still. That they still apply. Okay.
So x with a hat.
Yep.
Then sine, inverse sine.
Yep.
I mean, yeah, sine.
Yeah, inverse
And
sine.
brackets 1/2. Then 30.
That isn't an answer. That's why we're writing the hats. And then what do we draw?
All stations to central.
Then you ask yourself,
Is it TNC?
it is, where is sine negative? That's what you want to ask yourself. Where is sine negative? T and C. So therefore x equals, now do you remember the angle? 180.
180 plus 30.
180 plus, so 210. And 360 minus.
330.
Good job. E, cos squared x. Meta, this is your one. Cos squared x equals a quarter. Let me know when you're ready.
Yeah.
Okay. Now, you definitely have numbers on this right-hand side, so that's not a problem. But you've got this squared term, which we usually don't have on the left-hand side, so you've got to get rid of that first. Before you say what you're going to say, all I'm going to say to you is be careful with what you're going to say the right-hand side becomes. Okay, ready now? Cos x equals, what do you think?
Square root.
Yes.
Is it square root? Oh, okay.
You've forgotten something. I tried to say be careful, but it looks like you still missed it. You got to remember something when you deal with the squared, when you're trying to square root. Can anyone help us out?
Does it cancel out?
No, not yet. Don't worry about that cancelling out. Something else.
2.
Yeah, that will become 1 on 2. That's not a problem. Yeah, but still, something's wrong. Something's incomplete. Yes. Who just said that?
Me.
All right. Plus, minus.
Oh.
Plus, minus. Yeah, very important. You know that by now. If it's a square term, when you're square rooting, it's plus, minus, not just square root. All right. Does that make sense, Meta?
Yeah.
So we've got cos x equals, let's say, a half. Obviously, yeah, square root of a quarter is a half. So half. And we have, or cos x equals minus a half. Okay, let's start with this guy first. What are you going to do?
Just put in the calculator.
Yep. What are you going to put in the calculator then?
Cos
Inverse, right? Not just cos inverse of a half.
Yeah.
What does that give you?
1 second. Gives you 60.
And then you ask yourself, where is cos positive?
C and A.
Good job. Okay, in fact, there's a little trick with this. Can you tell how this one, you're going to go into x like this, you're going to do inverse cos of a positive half, which becomes 60 degrees, and you're going to ask yourself, where is cos negative, which would just be in S and T. So the trick you guys can memorize, if you ever have a squared term, it's actually going to be all 4, because the question you'll ask yourself is, where is cos positive? Well, that'll be here and here. And where is cos negative? Well, that'll just be here and here. You've already worked out the 60 degrees, so all you've got to do now is just do 180 minus and 180 plus. Do you get that?
Yeah.
Do you get how the answer is going to be actually all 4 of them?
Yeah, I got him.
Yeah, all right. Thank you. Anybody not understand what I've done there and how I got all 4? I mean, it would be the same as you saying x hat is equal to 60 degrees and then going and asking yourself, where is cos negative? You would have just said here and here. But I mean, you can memorize it. if it's ever a plus and a minus, you're just asking yourself, where is cos both positive and negative, which is going to be all 4. Okay, F. Are we starting to feel a little bit more comfortable with trig equations now? And maybe all stations to central as well? Natalia, T. Let's do sine x equals 0. So x equals?
0. Oh, sine, inverse sine, 0, but isn't that just 0?
That is 0. And then?
Where is it positive?
Yep, which would be?
A and S.
Yep, so your other answer is?
180 minus 0, so just 180.
Now, this one here is a very unique case compared to all the other ones, because all the other ones we only had technically for each, let's say for each equation, we had 2 answers, right? 1, 2. We had 1, 2, and then again for this one we had 1, 2. Yep, 2, 2. 2 answers. Now, this one, you're actually going to have a 3rd answer. Natalia, do you think you know what the 3rd answer is?
No.
I'll give you a clue. What is a number you're allowed to add to anything as long as you're not changing its position? What did we say? So if you're here, what number are you allowed to add so that you come back to here?
Wait, what do you mean?
So I'm here now. Imagine I'm here, right? What number am I allowed to add to this? What angle am I allowed to add such that when I do a revolution like that, I return back to here?
360.
Correct. So what is 0 plus 360? It's still 360 degrees. Now that is still in your domain, isn't it? So if you guys remember at the top when I was saying you're allowed to, like, it's good for you guys to know you can add as many 360s as you like. You're not doing anything. You're making the angles bigger. But these ones we've ignored, and the only reason why we've ignored them is because they're outside of our domain. But if I have an angle that is 0 degrees, if I add 360, that's actually still within my domain, so I must write that as my 3rd answer. So if you ever have 0 as an angle, the next answer will always be 360 degrees, because that's still within your domain. Do you get that? Natalia?
Yeah.
So just so you check something, look, add 360 to 180. Plug that into your calculator. What does it say?
0.
It has to be, right? Because all you've done you've taken 100. Well, it's still going to be 0 because you haven't changed the angle. You didn't add it by like 90 degrees or 180 degrees. You added it by 360. All you did was made the angle larger. But its position will always still be what? 0. But why can't I also put 540 in here? Even though 540 is right. Natalia, why can't I put 540?
Because then you get a negative.
No. So 540, I still got 0. I can't put 540 because my domain is from 0 to 360. So you've gone outside of your domain. It's too big. Otherwise, these can keep going. You can add 360 to this, and you can, sine 900 will still give you 0. But you don't put these ones in, and the only reason why we're not putting these extra ones is because they're outside of my domain. But 360, we had to put it in, because if I add 360 to 0, it's still within my domain. So you just got to be careful. If you ever get an answer of 0, another answer you must have, irrespective of the other answers, is 360. We haven't done that any other time because, like, if I got an answer of 90, if I'm going to add 360 to 90, I'm already going to be outside of my domain. So it's only 0 that it works for. Yes, soon. I've got more questions lined up for that. So this one has 3 answers. G, cos x equals 0. Natalia, V.
Yeah.
Let's do this one. Cos x equals 0.
Yeah.
X equals inverse cos.
So that's 90.
Yes, is inverse cos of 0 90? Yes, it is.
Yeah.
And then what are you going to do now?
So you can still do. Can you still do 360?
Wait, you're meant to do all stations to central.
And it's
Then
positive.
you meant to ask yourself where cos is positive. Yep, here and here.
Yeah.
So therefore x equals 90 and 360 minus 90, which is 270. You can't also have 360 degrees because the answer was equal to 0. I mean, like cos x was equal to 0. But your angle is 90 and 270. Here, the actual angle x became 0.
Yeah.
So that's what we added. Yeah. All right. Good. So it's just those two.
Okay.
And H. Nikki, last one. Sine x equals to 1. What are you going to do?
So you would do x equals sine inverse sine of 1.
Yep.
And then you'd get 90.
And then you draw.
All stations choose central. And then sine is positive in S and A, so you would do 180 plus 90. 270.
Minus. Plus is 10.
Yep.
So 180 minus 90 is still 90. And that's 90. So how many answers will you have for this one?
1.
Just the one answer. You're done. Let's do double angles. Okay. So we're going to start off with the top one now. Aiden, back to you. Tell me, what do you see is obviously different first before we start?
The 2 is
Yeah, the 2 is attached to this x now, right? So we are going to have extra things that we've got to do now compared to our normal ones where there were just x's by themselves. This isn't multiplied by 2 in front of the sign. It's multiplied by 2 with the angle. So you've got to leave that. The first thing you've got to still do is get rid of the sign. So Aiden, what are you going to do? To get rid of the sign.
Inverse sine?
Yep. So then you're left with what? You'll be left with 2x here equals?
Inverse sine 0.5. Which equals 32.
And then what did you always do now?
You draw all stations to
All stations to central. Sign is positive here and here.
Yeah.
You happy with that?
Yeah.
But, hold on now. But there's a little bit extra now that you've got to do. The extra bit is with respect to this 2x. So what 2x does, it tells you it's doing 2 revolutions. 2 revs, 2 revolutions. Okay? So it's not just doing 30 degrees and 150, it's going to go another revolution. So what are you going to do with that? If it's another revolution, what must you do to your answer of 30 degrees?
Do you add 720?
No, you just add 360, sorry. So the 2 revolutions is there just because it's the first answer and then your second answer. So just add 360. Yeah. 390. And you also add 360 to this guy.
Yeah.
Which is what? Now some students then go, oh, but Sam, didn't you say these are too large outside of our domain of 360? Well, they are, aren't they?
Yeah.
But what must you do with this 2 now? Put a 2 in front of a number, in front of your letter.
Do you divide everything by 2?
Yeah, right. So what you're actually going to get is 15, 75, 390 divided by 2, 195. 510 divided by 2, 265. 255. And look, is it all within my domain?
Yeah.
And if you didn't do these 2 revolutions, your answers would have only been these 2. You would have only had half of the answers. The logic of why this 360 needs to occur is because you're about to divide everything by 2, which means even if you had numbers that were too large, by the time you divide them by 2, they come within your domain.
Yeah.
Or you can just, I mean, some students even think of it as if it's 2x, you've got 2 sets of solutions. So that was one set, and this is another set of solutions. So the only other way you can get your second set is by adding 360 degrees to both of your angles. So add 360 to this and add 360 to this, and that's these 2 answers. Does that all make sense to you, Aiden?
Yeah.
Please don't divide by 2 first. I've seen a lot of students do that. Don't do that. You would divide by 3 if it's multiplied here. See that? It's multiplied. Yeah, maybe you will divide by 3, but if it's attached to the angle, you can't do it until the very last line.
Okay.
Cool. Anybody have any questions for this before we get going with it all? So we just kept it the same. All stations to central. The fact that it says 2x means you've got to add 360 again to this and this, because it's doing another revolution. And then at the end, you just divide everything by 2. Okay. If there's no questions, then we're going to move to Chan, who's going to try the next one for us.
All right.
All right. There's a few things in here because it's also a negative.
Yeah.
So be careful with that. Let's start with the negative first. So you're going to get 2x as a hat equals?
Invert cos half, which
Yeah,
is 60.
so every time you see a negative, you're just going to think of hats. Yep.
Yeah.
Inverse cos of a half is 60. Mm-hmm.
And then since it's negative, do you only look for where cos is negative? All stations to central?
Yep, all stations to central. Where is cos negative? You're saying here and here. So that means your actual 2x,
180
is
minus 120. And 60 plus 180, which is 240.
But you're almost there. See, if I didn't have a 2x, right? So if this was never there,
yeah,
this was never there, this was never there, full marks. That's exactly your work. Now, just making sure it's clear so everybody can see. It's exactly the same technique. It's just now at this stage, we add on an extra what?
360.
To both of those answers, yeah?
Yeah.
So 120 plus 360,
480,
and then 240 plus 360.
600,
So it looks like we're over, but by the time you're going to divide,
60, 120, 240, and 300.
and we're back in exactly what we wanted. Again, when your teachers are going to do this, you guys, 2x, they're going to make this into 720. They're going to times it by 2. That's their method. I'm not going to do it like that. You saw we're keeping everything as uniform as we can. And then all you got to remember is adding 360s because it's 2 times the sets of solutions, or it's doing your 2 revolutions, and done. All right. Giovanni, let's try C. All right, Giovanni.
Yep. Do we move the root 3 over first?
All right, good man. All right. 10 2x equals root 3, and you got to get rid of this 3. What are you going to do to it?
Over 3.
Over 3. I think you should be able to do that in one line by now. Good. And then?
You
2x
do
equals?
And
Yep. Root 3. 3. I've got my answer. I'll wait for you.
well, I messed up. 30.
Beautiful.
And then we draw the all stations central. And it'll be
Where is
A and T.
180 plus.
That would be 210.
And then what must you do as an extra now?
You add 360 to both of them. And you divide each one by 2.
You happy with that?
I'm happy.
This will be worth 4 marks in your exam. 1 mark for bringing it over, 1 mark for these 2, 1 mark for these 2, 1 mark for all 4. All right, D becomes x onto, interesting, okay. So if we had 2x, we got 2 sets of solutions. Let's see if we got half of x, what will happen. But we're going to keep everything as uniform as we can. Happy, let's do this one. Let's not change our method, and we'll see what we end up with. So x on 2 equals. Happy, you there?
Sorry, I was copying the thing down.
So x on 2, copying the top one down?
Yeah.
All right. Just let me know when you're ready.
Yeah, okay. So
So this one, x on 2 with equal to, and then what are you going to do?
I'm not sure.
Inverse cos. Wait, don't change. Don't worry about the x on 2. This, I'm trying to show you guys the angle doesn't matter anymore. Once you've understood the methods of how everything can work, you just continue. Go. Inverse cos.
So that would be 30.
Yep.
And then all stations to central.
Yep.
And we see where 30 is positive, which is A and C. So then 360 minus 30, which is 330.
Now some students say, okay, Sam, I'm meant to go and add 360. I go, there's no harm in doing that, right? I go, let's add 360, just so you guys can learn. It doesn't really matter. If you're doing it my way, it doesn't matter. So add 360 to this, you'll get this answer. Add 360 to this, you get this answer. Cool?
Mm-hmm.
Now, how are you going to get rid of this 2? No.
Do you times it?
Times. And times it by 2. So 60 degrees. But then what's going to happen to these answers? 780. Out. Why?
They're outside the domain.
Yeah, they're outside of my domain. So yes, the answers are right. Like, this is not wrong. This is not wrong. This is not wrong. If you sub them in, I promise you, it'll give you root 3 on 2. But they're just too big for our domain. So you don't need them. So you're only going to get one answer. So half of x means half the answers. Usually there's 2, you're only going to get 1. 2x, so double the x, you're going to get 4 answers. But I'm trying to show you guys, like, do more. It doesn't matter. Just learn. If you've got more, if it's outside of your domain, just cross them out at the end. It's not wrong. No one's going to mark that as wrong. Does that make sense, Happy?
Yeah.
Okay. Let's go with another one. E is tan x on 2 equals negative root 3. All right, Larson, let's do this one.
X over 2 equals inverse 10 bracket 3 root 3.
Good man. Okay, and then what's inverse tan of root 3?
Wait.
Yeah, that's
60.
Yep. And then?
All stations to central.
And what are you going to ask yourself?
Where 10 is negative.
Yep, which is?
T and
No,
8's S and T.
S, not S and
C.
Yeah, positive here, S.
C.
So x on 2 equals 180 minus 360 minus. Again, you can add more, but I think you know, but if you're going to add more, you're going to times it by 2, it's just going to be too big.
Yeah.
And 300 times 2 is also 600, so you're not even going to need it. So the only answer you get is just 240.
Yeah.
Good work. Last one. I'll do the last one. Root 3 tan x on 2 minus 1. Root 3 tan x on 2 minus 1 equals 0. I'll go up in case you guys are copying. Okay, this one, same thing. I can't have the minus 1 here. So I'm going to plus the 1 over. I can't have it multiplied by root 3. So I'm going to divide it by root 3. Inverse tan, 1 on root 3 becomes 30 degrees. And then all stations to central. Where is tan positive? Here and here. So I know the other one's going to be 210. When I multiply, I know this one's going to be too big. So my only answer is 60 degrees. And I am done. Okay. So now, feeling comfortable with that, we should be able to go up. And just do that style of question that I was saying here. So Find the exact value of sine theta and tan theta given that cos theta is this. So it's saying actually find sine and tan and cos theta is this, right? And the way we're going to do that is we said we're going to draw a triangle, which we did. We realized that that's just adjacent over hypotenuse. Wait, what have I done here? Adjacent. Oh, yeah, adjacent over hypotenuse. I was like, whoa, this looks weird. 3/7. And then we worked out our opposite side. From there, we can work out what our sine theta is and what our tan theta is. But before we got to that, we were asking ourselves this question. The fact that cos theta is negative. So Giovanni, for example, now with this question, let's see if you can get this out. Cos theta is negative, right? Giovanni,
Yeah.
you ready?
Yeah.
Right, so if cos theta is negative, you would have said, okay, if cos theta is negative, it's going to be here and in here, at least.
Yeah.
Right? Then you would, but then it's asking you, it's telling you, sorry, the angle has to be somewhere between 180 to 360. So it's somewhere from here to here. And if cos is negative and it's somewhere in here and here, that means it must be in the tan region. It can't be in the sine region. So if it's in here, that means tan is positive and all of them are positive. So therefore, these two are positive and these two are going to become negative. Do you get that?
No.
You get the fact that when cos is negative, it's in these two.
Yeah.
What bit's confusing is this bit here, right?
I think so, yeah.
Okay, so you've got that, and you also know that the angle, do you know what angles are going to be in here? Do you know what angles will be from here to here? Will be from 0 degrees to
90.
Yep, and then and then in sine, it will be from 90 to 190 to 180 degrees.
All right.
And then from here to here, it'll be 180 to 270 degrees, and then from here to here would be 270
It's 360.
to 360. Okay. Now it's saying it has to lie between 180 to 360, so it's got to lie at this bottom section.
Yeah.
So if it's got to lie at the bottom section, now you know it's not the S, it's the T. That's positive, because cos is not positive, cos is negative.
Hmm.
Do you get that? So like it's the only place where it's, yeah, okay. Maybe as we do another question, it might make a bit more sense. But now look, tan theta is very easy. It's just opposite over adjacent, and it's positive, so it's just root 40 over 3. Whereas sine theta is actually negative, and then opposite over hypotenuse, root 40 over 7. And that's the answer for the exact value of sine theta and tan theta. So let's do another one. And if I see that a lot of us are struggling with these kind of questions, we might actually do a few more from your textbooks just to get the hang of this. B. Larson, let's try B together.
Yeah.
Given that theta is obtuse, if theta is obtuse, what does that mean? That means it's greater than 90 degrees, but smaller than 180. So now you straight away know if theta is obtuse, where does it lie? In your all stations to central.
S and A.
S at least, right? And then the fact that it's saying sine theta equals 5 on A, of course that means S and A. So it's also positive here and here, which means in here it would be negative, and in here it also would be negative.
Yeah.
Question says find cos theta. Well, we straight away know that cos theta is at least going to be negative.
Yeah.
Then I now need to go and create what? To be able to actually work out cos.
Uh,
I need to create a triangle, because when I can create a triangle from sine theta, which is opposite over hypotenuse, and then work out this one here as 64 take away 25, 39. So that becomes root 39. Can you tell me what cos theta is now? Adjacent over?
um,
Over the hypotenuse.
hypotenuse, yeah.
Yeah,
Yeah.
adjacent over hypotenuse. Giovanni, does that make sense now? How I got this sign is positive here, the fact that it's obtuse.
Yeah, it's making more
A little
sense,
bit more.
I think.
Yeah. Should we do a few more of those?
Yeah.
Right. That's weird. Trig ratios. All the way down here. Alright. Alright. No, still find the exact value of these. It's not good. Looks like it's been missed. Until you get a question like this. Look, it was nowhere in your bloody exercises, and then you look at the chapter review and there's a question finally. Oh, these books kill my life. Okay, let's do this. So I think you can see the question here. Find the exact value of cos theta and sine theta. Tan theta is 3 over 5. So we're going to find cos theta and sine theta if tan theta equals 3 over 5. Giovanni, you want to try it with me?
If we go slowly.
Okay, go ahead. So what are you going to first do for tan theta equals 3 over 5? What must you draw?
All stations.
Find sine. No, because now you're not solving for theta. Sorry.
Oh, we did
So
the triangle.
Yes, if you're solving for theta, yes, you'll need to do what you're saying. But you're not solving, you're finding another 2 trig identities. So you have to draw a triangle. There's your theta, and this is...
The opposite would be 3, and the adjacent would be 5.
Yep, and then hypotenuse. Right? A squared plus b squared. 25 plus 9 is 34. So that becomes root 34. Now it's asking you to find sine and cos. I mean, yeah, sweet. You can just go say sine theta is, I don't know.
3 over root 34.
Yeah, like that, right? You could do that. But the idea is cos theta is adjacent of hypotenuse. The idea is though, sine is not going to be exactly positive and positive like this. What's going to happen if tan is positive, you look at your all stations to central, where is tan positive? Tan is positive here and here, which means what about your sine and cos?
I don't know.
If tan is positive here and here, what does that mean about sine and cos?
Should be negative.
Yeah. That's the actual answer we're looking for.
Oh, alright.
Simple?
Yeah.
Let's see if I can get you another question. Anybody else also struggling with that? Or you guys are starting, like it's starting to make more sense as I'm doing these questions. Yeah, not many in there. Let's see if Cambridge has it. Trig, yeah. Trig functions of a general rule. Given one trig function, find another. 258. There we go. So be careful. For those who are using Maths in Focus, it looks like they don't really have this in the book. And that's obviously part of the syllabus. So you've just got to be careful with that. Let's do maybe these ones. Okay. If cos theta equals 4/5 and sine theta is less than 0, which means it's negative, in other words, find tan theta. Okay. Who wants to do that with me to see if they're getting it? Mickey, then let's try this. Cos theta equals 4/5, and you know that sine is negative, find tan theta. Okay, what's the first thing you're going to do if you want to find tan or sine given cos? What must you draw?
Triangle.
A triangle. And can you again tell that this is different to the solving questions we were doing, right? When we were solving, we were just solving for theta. But now you're not solving for theta, you're solving for tan theta. So just be aware of that. All right, go, tell me. Theta's here, and then?
So it would be the adjacent would be 4 and the hypotenuse would be 5.
Yep. And then I think just the basic 3, 4, 5 triangle. You can work that out, but that becomes 3, 4, 5. It's telling you now sine theta is negative, right? But we will just quickly draw that as all stations to central. You know it's sine is negative. What else do you know? You know cos is
positive.
Cos is positive. So if cos is positive, that means what's A going to be?
Positive.
Positive, which means tan is going to be
Negative.
Therefore, what's tan theta equal to?
Negative of 3/4.
Perfect. You feel comfortable with that?
Yep.
I guess I'm getting used to, I'm sure. But can you guys go ahead and try B, please? I'll be right back. Just try B. I'll be back in a second.
Did anyone get negative 17 over 15?
What was that answer?
Negative 17 over 15.
Anyone gets negative 17 over 15? Okay, let's see. Anyone stuck with it? Doesn't know where to start? So I'd rather do it with you if you don't know where you're starting from. Anyone actually stuck?
Yeah.
Yep. All right, last one, let's do it together then. Tan theta equals negative 8 over 15. Sine theta is greater than 0, which means again it's just positive. Find cos theta. Find cos theta. All right. So first thing I'm going to draw is this triangle. It's theta. You can't put the negative in. That just tells you where it's at. So opposite over adjacent, 8 over 15. You got to work out the hypotenuse, which turns out to become 17. Does that make sense to you, Larson, so far?
Yeah.
Okay, and then we want tan to become negative. So that's a negative there. We know that sine is positive. Okay, if sine is positive, that means A is going to be positive, which means cos must be negative as well. And then cos theta equals negative adjacent over hypotenuse. 15 over 17. I think Giovanni, you said 17 over 15, didn't you?
Yeah, I've done it the wrong way around.
Yeah, be careful. It's going to be adjacent A over H. All right. Does anybody want me to go through that? Like do more questions, or are we okay by now? All right. Okay. I'm going to save that. Saturday advanced. I'll send that across to you guys. Start. Actually, we'll do our sine rule and cosine rule stuff, and we'll pretty much wrap up this topic. Okay, now for the easy stuff. Sine rule. The formula is just A on sine A equals B on sine B. What's really important about the side A and the angle A? Does anyone remember what must be super important about these sides and angles? How do you know which one to pick?
Is it they're opposite from each other?
Yeah, so they must be opposites of each other. So if we look at the very first one, it just says x. The angle you must pick must be opposite that. So x on sine 46 must equal to 15 on sine 70. And then obviously you just multiply this over and you plug it into your calculator. So x is 15 sine 46 on sine 70. All right. Natalia, V. Let's do this next one together. Just let me know when you're ready.
Yeah.
Okay. So we're going to write x on sine what?
A. Oh, sorry.
So the formula is
110.
like correct. 110 opposite equals 12.7 on sine
40. Oh,
nope. Has to be opposite. That's why I was emphasizing that.
yeah. Sorry.
So what's it going to be? If that's 110 and that's 40, that's 150, which means this must be what?
So it'd be 210. Oh, sorry. 3.
No. Hold on.
Sorry. Oh, sorry. Yeah.
The triangle is
Yeah, I
180
did
degrees.
60 in my head instead of 180. I mean,
Oh yes, no, yeah, just 180. 180 take away 150.
yeah, I don't know. I thought for some reason like I just got confused.
30. Yeah, that's okay then. 30 degrees, and then multiply it over. Plug it all into your calculator. That'll give you an answer.
1
All
second.
good. Yeah. And then the answer, we can check it as well. 23.9, hopefully.
Yeah, I got that.
Yeah, nice. All right. Obviously, when it's a theta, then it will look something like this. It will be like 17 on sine theta is equal to 12 on sine 30. You would have to cross multiply and then just divide by the 12 and then shift sign. So 17, let's have a look at it. 17 on sine 30 must equal to 12 on sine 30, sine theta, sorry. 12 on sine 30. And then cross multiply. Divide by 12. You're solving for theta, so what must you do to get rid of sine? You're going to shift sign or inverse sign the answer. And you don't do your all stations to central because you only want your first answer. You don't want the whole thing. The second answer, it's a triangle. Any questions? All right. Meda, let's do B together. Tell me what you would write. Order doesn't matter. Just tell me. Honestly, it doesn't matter. As long as you know they're opposites of each other, that's all that matters.
18
18.
over sine theta.
Sine, what's opposite 18? Is it theta?
Oh, no.
No. You remember it's opposites. 18 over sine
50.
50 must equal to
16.
16 on sine. Now
18. Oh,
it's missing an angle, right?
yeah.
But you have to label that. Let's label that as x. So the trick with this question is, what letter are you meant to solve for? You're actually going to solve for x. Once you find x, we're going to be able to do angle sum of a triangle and work out theta.
Okay.
Can you see that happening? So you can't write 16 on sine theta because it's not opposite it. So you must make another one here, find the x, let's call it, and then angle sum of a triangle. So let's do that. We're up to this stage here.
Mm-hmm.
What are you going to do now?
Cross multiply.
Cross multiply. So you have 18 sine x equals 16 sine 50. And then you don't want the 18 here. What are you going to do to that?
Divide it.
Then you're going to plug all of this into your calculator. Can you try to do that for me?
Yeah. Is it 16 sine 50 over
Over 18. 18.
16 sine? It's like 0.868.
68.
Yeah.
And then inverse sine.
Oh,
You get about 42.9,
yeah.
which becomes 43 degrees.
Mm-hmm.
So now you know this is 43. And what can you tell about theta?
180 minus
50 minus 43, and then
87.
yeah. Does that all make sense?
Yeah.
Key thing to that question, just like all of them that we've been doing, opposites. So you can't choose like 18 over sine theta, or you can't say 18. So it has to be opposite that side, opposite that side, or opposite that angle is a side, and so on. So you can't actually work out theta. The only way you can work out theta is by working out the other angle and then subtracting. Cool.
Sam, aren't they meant to be like to the nearest minute?
Is that what it said? Oh yeah. Oh well. I did it to the nearest degree. I'll lose a mark. I'm sorry. I'm sure you guys all know that. If it's nearest minute, sine x equals 0.68. So I'll go back to that one. Shift sine to the nearest minute. This answer should be 42 degrees, 55 minutes, which means the final answer becomes 180 minus 50 minus that, 87 degrees, 5 minutes. If you're rounding your minutes, you got to look at your seconds, and if it's 30 or more, you round up. If it's 30 or less, you round down. Sorry, 29 or less, you round down. Okay, cosine rule. C squared equals, does anyone know what the cosine rule, or does anyone remember what the cosine rule was? Okay, cosine rule, the first bit is Pythagoras. So c squared equals a squared plus b squared minus 2ab cos c. A and b are sides. Cos c, capital C, this must be angle opposite the side you want to find. this cos C must be the angle opposite the side you want to find. Okay. Nikki, can we do question 1A together?
Yep.
So, x squared equals your first side. Give me a number for your first side. A squared.
17.
Yep. Plus
18.
minus 2 times
17.
times
18.
times cos.
Would it be
The-
100? Oh no, it would be x.
No, you were right. You were right. Hold on. This is an angle. Theta, cos, sine, and tan. Whenever you've got a value there, it must be an angle,
Okay.
not a side. So
Yeah.
it was cos 110, and let's see if that's true. This angle C, the reason why we chose the letter C here, not like A and B, is because that C must be the exact opposite of that C. And let's see, that's what you're trying to find, and these two are opposites of each other.
Okay.
So, perfect. And then what must you do at the end? You've got to square root it. So whatever, plug all that into your calculator and square root. Why don't we write plus minus when we're square rooting here?
Because you're just finding x.
Yeah, it's a distance. So it's got to be positive. Cool. B is exactly the same. It's opposite.
So the answer is 28.6. 28.8. No, 28.7.
28.7. Yeah. Good job. B is exactly the same. I was just going to say, like, look, you can see I've only got like 2 questions in here. The only reason why I've put 2 questions is because you really don't need that many to solve for like cosine rule. You're only going to get 1 question in your whole exam that's about sine rule or cosine rules and bearings and stuff like that. So it's not a big issue. This is more like year 10 content. So it's not really tested in the HSC or anything like that. Okay. Question 2. Find theta to the nearest minute. To find theta, you need to now have a formula for cos C. This one here would be like this. Cos theta equals, sorry, cos C. Cos C equals A squared plus B squared minus C squared over 2AB. These formulas will be given to you in your formula sheet if you're having problems memorizing them, but I think you guys know where I stand with that. You should have it memorized if you want to perform well. Okay, again, very important. The angle you're going to find, this subtraction sign must be opposite the angle. So this side must be opposite this angle. This side must be opposite this angle. So, Natalia T, let's try question 2A.
2A.
So cos theta, yep, this one here. What's going to be your A? What do you want your A squared to be?
Adjacent, so 6.
Not really. Yeah, 6. It's not really adjacent. Adjacent and stuff is only for right angles. These are just letters A, B, and C.
Over 8.
Plus, so 6 squared. No, 6 squared plus B.
7 squared.
No.
8 squared.
8 squared minus.
Minus 7 squared.
Why? Because this C must be opposite the C you want to find. So that's the angle. That must be opposite. So that must be a C. These guys don't matter, whichever one's A and B. Over 2 times
6.
times
8.
Yep, and then you just plug all of that into your calculator. And then what do you do to get rid of your cos?
You move to the other side.
How?
You
How do
times.
you
You divide.
cos? Come on, think about it. That's what we've been doing.
Oh, inverse cos.
Yes. Yes, inverse. 6 squared plus 8 squared plus 7 squared. Inverse cos. I get an answer to the nearest minute. 57 degrees. 55 minutes. Aiden, let's do this one here.
Yeah.
Cos theta equals, that's
theta
6 point.
equals 6.1 squared
6.1 squared plus
plus 5.2 squared
5.2 squared minus,
minus 8.7 squared
correct, that's going to be at the end, over 2 times,
over 2 times 6.1 times 5.2.
and plug it all into your calculator, shift cos, we're going to cheat a little bit, and there, it'll look like that, that's what it becomes, and then when you inverse cos, it becomes 100 degrees. Any questions? Okay. And last one, area of a triangle. Area of a triangle, again, it's half AB sine C. Again, this is a side, that's a side, that's an angle opposite the side you don't use. So if that's A and that's B, this must be an angle of a side I don't use, and you can see that. So the answer for this is literally half times 17 times 18 times sine 110. Half times 294 times 316 times sine 35. So just out of curiosity, they gave you this as like 110, 145, and then this becomes 35. So if they gave you something like this, the idea is if you've used 316 as your side, you can't use that angle. If you've used 294, you can't use that angle as your angle, and then if you haven't used that side, you can use that angle. So that's how these A, B's, and C's work. Obviously, this is just going to become 2 triangles. Same thing as this guy, 2 different triangles, 5 different triangles. Yeah, these are easy. I think I'm happy to stop there and do some exam questions.